All right, let's run through this replacement test practice. I wanted to mention at the beginning here that even though you're allowed to use a calculator, this test was designed so that you don't need to use a calculator. So I'm going to be working through this without using a calculator. So question number 1 says, solve the following system. Now notice here that, that we've got this z by itself. We don't have an x or a y in this. So this is where we're going to start. 2z is equal to -2. So if we divide both sides by 2, we're going to get that z is equal to -1. And then we're going to use that to solve for y using this equation. So we get 2y plus 5 times -1 is equal to 7. So 2y minus 5 is equal to 7. Add 5 to both sides, we get 2y is equal to 12. So y is equal to 6. Let me box in these answers so that we can put those in later. And then now we're going to use those two answers to find x from the top equation. So we have 4x plus 5 times y, which we know is 6, plus 6 times z, which we know is -1, is equal to 4. So 4x plus 30 minus 6 is equal to 4. So add 6 to both sides. That's going to be 10. And then subtract 30 from both sides. That's going to be -20. So 4x is equal to -20. So x is equal to -20 divided by 4, which is -5. So let's come over here and put in that our x is -5, our y is 6, and our z is -1. All right. Number 2, compute the following determinant. So what we're going to do for a determinant is this number times this number, so 1 times 1, minus this number times this number, so 2 times -4. So this is going to be 1 minus -8, so that's 1 plus 8, which is 9. And so our determinant here is 9. All right, next, graph the parabola. So remember that our standard form for a parabola is either x minus h is equal to, x minus h squared is equal to 4p times y minus k, or y minus k, should be k squared, is equal to 4p times x minus h. And this, if the x is squared, then it's either going up and down, or it's either going up or it's going down. If the y is squared, then it's either going to the left or to the right. All right, here we can see that that the y is being squared here, so we're going to use this one. Let's cross out this one. So we want to make this look like this. So we get, so let's first subtract 4 from both sides. So we get x minus 4 is equal to 2 times y minus 7 squared. So we're pretty close to making this look like this, but notice that this coefficient here, this 4p, is in front of the term that's not being squared. So we need to get this over here. So we can do that by multiplying both sides by 1/2. 1/2 times 2 is just going to be 1, and so we get y minus 7 squared by itself. And then on the other side, this 1/2, we get that 1/2 times x minus 4. And now this is in standard form, so we should be able to graph it from this. So let's first choose our parabola shape. We're going to, we can see that the vertex is at, the vertex here is going to be at 4 from this. It's the number we're subtracting from x. 4, and then 7, the number we're subtracting from y. So our vertex is at 4, 7. So 4 and 7. And the y is being squared, so we know it's laying on its side. And our p is positive, so it's going to be going this way. And now we need to find one other point. Here's what I usually do when I'm trying to find another point. I'm going to go to this term that's being squared here, and I'm going to plug in some number so that this whole thing inside the parentheses is 1. So that's going to be 8. So let's make y equal to 8. And if y is equal to 8, then 8 minus 7 is 1, squared is 1. So we get 1 is equal to 1/2 times x minus 4. And if we distribute that 1/2, we get 1 is equal to 1/2 x minus 2, and then add that 2 to both sides, so we get 3 is equal to 1/2 x. So x, if we multiply both sides by 2, we get x is equal to 6. So, so we're going to have this other point is going to be at the point x equals 6, y equals 8. Because we've figured out that when y is equal to 8, x is equal to 6. So that's going to be our other point. So we have 6 and 8. That's our second point for that parabola. All right. Continue on to number 3. Find the equation of the parabola with vertex 3, 3 and focus 3, 9. So let me sketch a little graph here. So our vertex is at 3, 3, and our focus is at 3, 9. And the parabola always opens toward the focus and away from the directrix. So it's going to be going up like this. So we know that our x is going to be squared, and our p is going to be positive. And we're given the vertex, so h and k are both 3 in this case. So we get x minus 3 squared is equal to 4p times y minus 3. Now we just need to figure out what that p is. And p is this distance. Draw that well. That distance is p. And we can see that that distance, the distance between the point 3, 3 and 3, 9 is 6. 9 minus 3 is going to give us 6. So if p is 6, 4 times p is 24. And so that's the equation that we're going to enter right here, that we've got x minus 3 squared is equal to 24 times y minus 3. All right. Next, find the vertex, focus, directrix, and axis of symmetry of this parabola. So let's sketch this. Well, let's find the vertex first. We can see that the vertex is what we're subtracting from 2, or subtracting from x, which is 2, and then what we're subtracting from y, so that's going to be -5. So our vertex is 2, -5. And then let's sketch a little graph here. So we've got our vertex at 2, -5, and And let's see, we know that this is opening to the side. It's laying on its side because the y is squared and not the x. And the p is negative, so it's going to be going this way. So we know that our parabola is going to be going this way. We don't know the exact shape yet, but we know it's going to be lying on its side like that, which means that its directrix is going to be out here, and its focus is going to be in here. All right, so to figure out what that where that focus is, we need to figure out what the p is. So remember that this is equal to 4p. So 4p is equal to -3. So p, if we divide both sides by 4, is equal to -3/4. So what we need to do is add 3/4. We need to move in this direction 3/4 from our vertex. So our vertex is at 2, -5. That -5 is not going to change, but the focus then is going to be 2 minus 3/4. So that's 1 1/4 or 5/4 -5. All right, then the directrix is going to be this vertical line here. So we know it's going to be x equals. X equals is a vertical line. So this is our directrix. And it's going to be x equals, and it's that p is going to be over here as well. That distance is going to be p. And so we're going to add 3/4 instead of subtracting 3/4. So we're going to get 2 plus 3/4, which is 2 3/4, which is 11/4. And there's our directrix. And then our axis of symmetry is going to go right through the vertex. So here we can see that it's a horizontal line. So the axis of symmetry is going to be y equals, and it's going to go through our vertex. So it's going to be y equals -5. So let's fill in those answers. We've got a vertex at 2, -5, a focus at 5/4, whoops, 5/4 and -5. And our directrix is x equals, and it's x equals 11/4. And our axis of symmetry is y equals, and it's y equals -5. All right, number 6. Find the focus of the parabola. So in order to do this, we first need to put this into standard form, which means that we're going to have to complete the square here. So what I'm going to do is I'm going to leave the y's, because the y is being squared. I'm going to leave the y's on one side. I'm going to get everything else to the other side of the equation. So let's write this as y squared minus 4y is equal to -5x plus 16. Now we're going to need to get this into some form where we have something squared, some term or some expression in here squared, and which means we're going to have to complete the square here. So we're going to do y squared minus 4y, and then we need to add something here to complete the square. And what we're going to add is we're going to divide this by 2. So -4 divided by 2 is -2. Squared is +4. So we're going to add 4 there. But if we add 4 there, we have to add 4 to the other side as well. Let me get rid of this. So this now factors to y minus 2 squared. It's always, that's why we added that 4, was so that it could factor really nicely into this y minus 2 squared. And then on this other side, we're going to get -5x plus 20. And the last thing we need to do to get this into standard form is we need to factor out a -5. So we have y minus 2 squared is equal to -5 times x, and then 20 divided by -5 is going to be -4. All right, so here we can see that the vertex of this parabola is going to be at 4, 2. The number we're subtracting from x, and then the number we're subtracting from y. So we're at 4, 2. Here's our vertex. And we know that the y is being squared and the p is negative, so it's going to be coming down this way. And so our focus is going to be somewhere in here. And we need to figure out what that p is. Well, 4p is equal to -5. So p is equal to -5/4. So this is going to be, we're just going to take our vertex at 4, 2, and we're going to go in this direction, -5/4. So we're going to subtract 5/4 from our x. So 4 minus 5/4 is going to be 11/4. Our focus is going to be at 11/4 and 2. So let's plug that in. 11/4 and 2. All right, that was a lot of work on that one. But please make sure that you put some answer in there so that I can give you some partial credit. I will be reviewing these tests. I won't be just trusting the grade that that Alex gives us, because I know that that's a lot of work, and just a small mistake could end up getting you a wrong answer. All right, write an equation of the circle with center 5, -9, and radius 7. So the equation for a circle is, we've got x minus h squared plus y minus k squared is equal to r squared. So for this one, h and k are the coordinates of the center, and r is the radius. So here all we need to do is just plug in h and k. So here we have 8x minus h, which is 5, squared, plus y minus k, which is -9, so it's going to be +9, squared is equal to r, which is 7, squared is 49. So let's enter that equation here. So we've got x minus 5 squared plus y plus 9 squared is equal to 49. There's our equation for that circle. All right, now an ellipse. So the equation for an ellipse is going to be x minus h squared over a squared plus y minus k squared over b squared is equal to 1, where h and k are the center of the coordinates for the center of the ellipse, and a is the distance out on the x-axis, and b is the distance on the y-axis. So so here our center is going to be at -2, 3. So let's go ahead and graph that. So we have an ellipse, and our center is at -2, 3. So there's our center, and the A is going to give us the distance we go on the x-axis. So we're going out here on the x-axis 6, because 36, the square root of 36 is 6. So we're going out 6 in this direction. So there's 2 3, 4, 5, and 6. And then in the y direction, we're going to go 5 because the square root of 25 is 5. So there's 1, 2, 3, 4, 5, and there's our ellipse. All right, find the center, vertices, and foci of the ellipse. Simplify your answers as much as possible. So the center, vertices, and foci. So the center we can just read off. It's the number that we're subtracting from x, so that's -1, and the number we're subtracting from y, which is 2. And now let's take a little graph of what's going on here. So we're at -1, 2. There's our center, and then we're going to go out 8 in the x direction. So that's going to put us, say, here and here. And then we're going to go out 10 in the y direction. So we're going to be up here and down here. And then there's our ellipse. And what we need, so the vertices are going to be these two. Let me put those in a different color. So these are the vertices that we're looking for. These other two, those are the co-vertices, and we're not asked to find those. So to find the vertices, we're just going to take our center, so -1, 2, and we're going to add now, we're going to add 10 and subtract 10. So we've got vertices at -1, 12, and at -1, and then 2 minus 10 is going to be -8. All right. And so now to find the foci. The foci are going to be on the same axis as the vertices. So the foci are going to be out here and out here somewhere. And to find that the foci, we need to find this distance, which is c. And c squared for an ellipse is going to be equal to a squared minus b squared, or b squared minus a squared. And in this case, it's going to be b squared minus a squared, because b is bigger than a in this case. So it's just going to be the difference between these two. So c squared is going to be equal to 100 minus 64, which is 36. So c is going to be equal to 6. So this distance is going to be 6. So we're going to find our foci the same way we found the vertices, but instead of adding 10 and subtracting 10, we're going to add 6. So 2 plus 6 is 8. And subtract 6. So 2 minus 6 is -4. All right, so let's come over here and enter that our center is at -1, 2. Our vertices are at -1, 12, and -1, -8. And then our foci are at -1, 8, and -1, -4. All right. Now it says find an equation of the ellipse having a major axis of length 6 and foci at 1, 1, and -3, 1. So let's draw what we're talking about here. So we have foci at 1, 1, and at -3, 1. Okay, so right off the bat, let's just find our center, and I'm going to mark this center here in red. So the center is going to be halfway between these two. So we know it's going to be at 1. So the center is going to be the y-coordinate we know is going to be 1 because it's 1 in both of these. We're just taking the average of these 2 points. The average of 1 and 1 is 1. The average of 1 and -3, well, 1 plus -3 is -2, divided by 2 is -1. So our center is at -1, 1. So already we can start to write our equation for this ellipse here. By the way, we know that the major axis is going this way. So, so this ellipse is going to it's going to come out like this. So it's our major axis is parallel to the x-axis. So our bigger number is going to be under the x. So this is going to be x minus -1, so +1, over something, plus y minus 1 over something. This is going to be squared, both of these, is equal to 1. And now we just need to figure out what these two somethings are. So this down here is going to be this distance out to here. This is A. And we're told that the major axis is 6. So this entire length is 6. So this length has to be 3. So what goes under here is 3 squared, which is 9. And now to figure out what goes here, we need to figure out this distance. And to figure that out, we know that c squared is equal to a squared minus b squared. And we know that c is this distance here, which is 2, the distance between that center and the, in between -1, 1 and 1, 1, that distance is 2. So 2 squared is 4. And this distance a, we already said, is 9. So 4 is equal to 9 minus b squared, which means that b squared has got to be 5. And so this number right under here is 5. And so we're going to come up here and we're going to enter, let's put a fraction in there. Oops. I don't know what this is going to be x plus 1 squared over 9 plus y minus 1 squared over 5 is going to be equal to 1. All right. Number 11. Find the foci of the ellipse. So this is another one where we're going to have to complete the square in order to figure out what the foci are here. So let's put this into standard form by completing the square. We're going to put the x's together and the y's together. Well, we've got 9x squared plus 4, and let's factor out the 4 out of this out of these y's here. So this is going to be 4 times y squared plus 6y, and then leave some room to complete the square, equals 0. All right, so what do we have to add here? Well, we're going to divide the 6 by 2, that's 3, and so we're going to add 9. And so by adding 9 in here, what we've really done is we've added 36 to this side of the equation, because 4 times 9 is going to be 36. And so we have to add 36 to the other side of the equation. All right, so this gives us 9x squared plus 4 times, and this factors to y plus 3 squared, is equal to 36. Now, remember that the equation of an ellipse is always equal to 1. So we have to divide both sides of this equation by 36 to get this equal to 1. So if we divide by 36, we get 9 over 36 is the same as 1 over 4, so x squared over 4, plus 4 over 36 is the same as 1 over, what would that be, 9. And that's going to be equal to 1. So there's our equation for our ellipse, which means that our center is going to be at 0, -3. And to find the foci, so we've got our center at 0, -3, and we're going out 2 in the x direction, up 3 in the y direction. So we're going to go, there's our ellipse. And our foci are going to be out here. And we need to figure out what that distance is there. So c squared is equal to b squared minus a squared. So c squared is equal to 9 minus 4. So c squared is 5. So c is equal to the square root of 5. So that's this distance there. And so we're going to be at, our answer is going to be 0. The x is going to be 0 for both of these. And the y is going to be our -3 plus the square root of 5. And -3 minus the square root of 5. Whoops. So there's the answer for number 11. All right, now graph the hyperbola. So to graph this hyperbola, the y is first. So with a hyperbola, if the y is first, then we know it's going to be going. It's gonna look like this. And we know that the center of this hyperbola is going to be at 3, 2. So we've got a center at 3, 2, and the parabola is going to look like that. So let's come over here and choose our parabola. Our center is at 3, 2. Here's the center. And then this, the vertex is going to be up, and this distance, if I can draw on here again, this distance is going to be our what's under the y. So that distance there is going to be 5. So we're going up 5. So that's going to be up to 7. And then this distance under here, this is over 1. So that's going to be our distance in the x direction. So we're going to make this little box here by going out 1. Man, it's really hard to see on this. Oh, I see. I want this to go out to 4. Never mind. I don't know that I placed that correctly. That should have been up here, actually. Let's do that again. Let's go back. We want our center at 3, 2. so many lines on this that it's really hard to see. We want to go up 7. And then on that same line, let's just go over 1 to 4. And there's going to be our hyperbola. All right. All right, find the center, vertices, foci, and asymptotes of this hyperbola. So the center, we can see right away, is going to be at 6, -9. 6 and -9. Now, let's sketch a little graph here. Our y is first, and so let's go out to 6, -9, and we're going to be up here and down like this, since the y is first. We're subtracting the x from the y. So our vertices, this distance is going to be our b, our number under the y. So we know this is 5. So we're going up and down 5 from here. So we're going to add that and subtract that from the y. So our vertices are going to be at 6. -9 plus 5 is -4. And 6, -9 minus 5 is -14. All right. And then the foci, this distance, we've got the foci here and here, and this distance is c. And in the case of a hyperbola, c squared is equal to a squared plus b squared. So, c squared is equal to 49 plus 25. So c squared is equal to 49 plus 25 is 74. So c is equal to the square root of 74. And we're going to add and subtract that from our y coordinate, just like we did for the vertex. So we're going to, the x will stay the same, 6, and now this is going to be -9 plus the square root of 74, and this will be 6 and -9 minus the square root of 74. All right, finally, the asymptotes. So the asymptotes are going to be, the equation for the asymptotes for this are going to be, for a hyperbola, are going to be y minus k is equal to plus or minus b over a times x minus h. So here we've already got y, so this is y minus 9 is equal to, and then x minus h is x minus 6. And then this b minus a is just this, this number, the 25, the square root of that over our a, which is 7. So 5 over 7. So this is plus or minus 5 over 7. And then to get this equal to y by itself, we'll just add 9 to both sides. So y is going to be equal to 5/7 times x minus 6. Oops, we better put that in parentheses. Are we not able to put, oh, I guess it doesn't want to allow us to put that in parentheses, so we better distribute that. So we've got y is equal to 5/7 x. 5/7 times 6 is 37 plus 9, which is 63/7. That's going to be what, 93/7. That's an ugly equation here, but so plus 93 sevenths. And then on the other side, we're going to get negative 5 sevenths. So the other equation here, negative 5 sevenths x, and then this would be, if this is negative, this will also be negative. And so adding those together, we're going to get 33 sevenths. So plus 33 sevenths. All right. That was a difficult problem, but remember to do as much of that problem as you can, because you'll get partial credits. For example, for finding the center of that hyperbola. All right, find an equation of the hyperbola having foci at negative 9, 5 and 9, 5, and vertices at negative 3, 5 and 3, 5. So let's sketch a graph of what's happening here. So negative 9, 5 and 9, 5. So if those are the foci, then the center has to be right here in the center at 0, 5. So our center is going to be at 0, 5. So that's half the battle here, because now we know that if our vertices are out here, the vertices are here and here, and so this is going like this. So we know the x is going first, so x minus 0 over something squared minus y minus 5 squared over something is equal to 1. And then this distance that we're going out here to the vertices is 3. Let me change my color back here. This distance is 3, so that's going to go under our x. So 3 squared is 9, and then the other distance, our b, we need to figure that out from our a and c. So we know that c squared is equal to a squared plus b squared, and the c, this distance here, is 9. So c squared is 9, so that's 81 is equal to, or sorry, c is 9, so c squared is 81. The a is 3, so so a squared is 9 plus b squared. So b squared is equal to 81 minus 9, which is 72. And so that's what's going to go under here. That's going to be 72. And so let's write that equation right up here. We're going to have x squared over 9 minus y minus 5 squared over 72 is equal to 1. All right, last one. First, we're asked to find, to figure out what kind of conic sections these are. So here we can see that both let me draw on this, both the x and the y are squared. So we know it can't be a parabola. We also know that both the coefficients on the x and the y are both positive. So it can't be a hyperbola. And we know they're different, so it can't be a circle. So this has got to be an ellipse. So let's choose an ellipse for this one. And then it asks us to find the center. So in order to find the center, we need to put this into standard form. We need to complete the square. So let's put the x's together and the y's. So we get 16x squared plus 64x plus 4y minus y squared minus 8y is equal to -4. All right, now let's factor out 16 here so that we just have x squared by itself. So this is 16 times x squared plus 64 divided by 16 is 4x, and then we'll leave room to complete the square, plus factor that 4 out, and we get y squared minus 2, leave room to complete the square, is equal to -4. And so now, to complete the square here, we need to divide this by 2 and square it. So this is going to be +4. And then divide this by 2, that's -1, squared is +1. But now we've added some stuff to this side, so we have to add some stuff to this side. Here, this is 16 times 4, which is 64. So we have to add 64 to this side. And then here's 4 plus 1, 4 times 1. So we have to add 4 to this side as well. All right, now we get 16 times, we can factor that to x plus 2 squared, plus 4 times, factor that to y minus 1 squared, is equal to, well, this -4 and that +4 are going to cancel, so this is 64. And then we divide both sides by 64 to get this equation, but all we need to know is the center, and we've got enough information now to put in the center. The center is going to be at -2, that's the number we're subtracting from the x, and then +1, the number we're subtracting from y. All right, this second equation here, we've got -2x squared plus 8x minus y equals 9. So here, the x is squared, but the y isn't. So we know that that's got to be a parabola. And now we need to find the vertex. So again, we're going to need to complete the square. So let's get the x's on one side and everything else on the other. So we have -2x squared plus 8x is equal to y plus 9. And now we'll factor that -2 out. So we get -2 times x squared minus 4x, because 8 divided by -2 is -4. And then we'll leave some room to complete the square, is equal to y plus 9. And then to complete the square here, -4 divided by 2 is -2. So -2 squared is +4. And here we've added 4 inside the parentheses, so what we really added is 4 times -2, which is -8. So we have to add -8 this side as well. And so what we end up with here is -2 times x minus 2 squared is equal to y plus 1. And so we're not completely in the right form now, but we've got enough to find the vertex. The vertex is going to be 2, because that's what we're subtracting from the x is 2, and then what we're subtracting from the y is -1. So this is 2, -1. And that's it. That's our practice test. It took us a little bit of time, but if you work through these and know how to do these, the test is going to be very similar to this. So know how to do this before you start that test, and good luck to you all.